Bio. Micah is a mathematician who makes pictures to try to understand hockey. He lives in Halifax, remember that point, and is employed by the public who subscribe in droves to his website, hockeyviz.com. Micah, where are you? I know you're here. Come on, let's do this. So what time did you leave your house yesterday, Micah? Okay, so he left his house at 9 a.m. in Atlantic. His flight was canceled. He drove to Moncton, which is how long?
Oh, no, I said I drove to Moncton, but did not.
Oh.
Instead, had to stay in the airport for 3 hours.
Okay, stays in the airport for 3 hours, flew out of Halifax. Okay, then missed his connection, but said he was going to get here either last night at midnight or this morning at 9:30. He missed his flight here this morning because he was delayed in customs. And is it true you were actually trying to convince them that you were actually speaking here?
Yes.
He was showing them tweets from the conference to convince them he was speaking here. When he missed his flight, he then flew to Pittsburgh and then drove here, people. So please, for the master, a warm round of applause.
How do I click?
Page down.
All right. All right, thank you very much. It is, perhaps we will take it today when I tell you that I am extremely pleased to be here, that it is not an empty platitude designed to ease you into my talk. That said, many of you, if you know me, and a lot of you do, you'll know that I tend to talk very fast and that I have a lot to say. Today I have one thing to tell you, one very simple thing. I'm looking at score effects, and it says score sequence effects, so we'll get to the sequences yet. So first of all, we're talking about score effects. What are we talking about? We're talking about how losing teams dominate play. We already saw it in Megan's talk. I'm sure it's come up many, many times in the talks that I wanted to see. That when you are losing, you get more of the puck. Every single person who's watched an NHL game has seen it happen. Leading teams have less of the puck, trailing teams have more. That's not to say that the losing teams normally win, the losing teams normally lose. So what is causing it? And the one thing I'm going to tell you, the one thing I'm going to show to you today is that the primary cause of the effect is not the trailing team, it is the leading team. There you go. It's taken me 6 years, now you get to see it. So, and part of the little wedge, this is not the most interesting thing, but this is the way we're going to get into it. The wedge is we're going to look at when the goals are scored. Not just the score, but when were the goals scored. Is this, are we looking at a comeback? Are we looking at a lead being extended? Are we looking at a tie? What kind of tie? We're not even going to look at the times that the goals are scored, just the order. Actually, we are going to kind of look at the times a little bit. And so, I like to lie in my talks constantly, but there's not a lot of lying in this talk. In fact, surprisingly little. But what I'm going to prove to you, what I'm going to, I hope, convince you of, is, I would not have come all this way if I didn't have a certain amount of faith in my persuasive abilities, that the leading team is the driving effect. I'm also going to show you that they can turn it back on when they like, if they decide that they no longer want to sit back. And we're also going to discover a little tiny scrap of truth behind the idea that 2-goal leads are the worst leads in hockey, and also we're going to discover that momentum of teams playing better after they score goals is a real thing, but not maybe that big. All right, that's a lot of stuff. So here's score effects. This is an observational picture of what score effects look like. So this is from the home team perspective. So tied, plus 2.9%. What's that? We'll get to that in a second. More, better, more stuff, more hockey, more good for the home team when they're tied. Less for the away team. So the away shots are on the bottom. Blue means less, red means more. And so in this case, this is a map of the shot patterns that are taken, purely observational, 5-on-5. This is all 5-on-5 data. I'm using 2016 to 2019 exclusively. So the home team gets more shots. Okay, that's great. You didn't need me to tell you that. And then when the home team is down by 1, all of a sudden they get more shots. And the units there, the numbers there, I like pictures. Numbers are bad, really bad. I tolerate numbers to get where I need to go. The only reason you do a math PhD is so that there are no more numbers. It's the only place to be safe. You think I'm kidding? That's it reads like a laugh line, but it's God's honest truth. So when teams that are losing, that 8.7, that means if you take all of that pattern of shots, multiply the number of shots, the rate of shots at each point by the league average scoring percentage at that point, because certain places are more dangerous to shoot from. Like, I think we got that covered this conference too. And then just add up how many goals you get and then compare that to league average. So we're looking at skaters only, and we're not looking at their shooting talent. You know, so if Ovechkin takes this shot or if Patrick Laine takes this shot, it's going to be different than if a player who you would laugh at if I said here. And so that 8.7% means 8.7% more goals. So that's not a huge effect, but it's very noticeable. 8.7% more for the home team when they're down 1, and almost 11% less for the road team when they're down 1. And you see the pattern extending in the same way the other way, although it's less easy to see when it's up 1, because of course there's still home team effects. So we're actually not going to talk too much about home team and away team, but what I want to get a hold of is I want to isolate the effect of the score itself. But this is tricky in all the obvious ways, the way that hockey constantly is, because other things are changing as the score changes. In particular, this is the first thing I ever did in hockey, the very first thing. People ask me constantly because I don't know why they ask me specifically, but they do ask me what they should do to get into hockey analytics. And one of the things that I always tell them is you have to have your own problem. It has to be interesting to other people, and you have to learn how to communicate it, but if it's not your own issue, if it's not something you don't understand, then you won't get anywhere. You won't have any drive to fix it. And so this is the first thing, I remember watching it, and somebody more knowledgeable, I don't remember who it was, somebody much more knowledgeable than me said, oh yeah, the leading team doesn't normally get as many shots. And I thought, why not? They're better, they're ahead. Why don't they have more of the puck? And so, I mean, the obvious reason, of course, is because they don't need to score as much. But then I thought, okay, so do they play differently? Do they play different players? And so as soon as you start asking this question, you think, well, okay, we're going to have to come up with some sort of model to encompass those things. So we want to isolate the effect of the score itself from the player abilities, because players are going to be changing all the time. In particular, certain players play more when their team is losing, and other players play more when their team is leading. We want to keep track of home and away. We want to keep track of the time in the game, because we expect that if there's a real thing going on here that's driven by the circumstances of the game. After all, the thing about the score is that it doesn't matter until the end of the game. So that's a basic observation for you. But in particular, if you want to think of that continuously, you can think of it steadily mattering more and more and more as the game goes along in a continuous way, which we all do. And then, but the thing I'm going to look at, the extra thing that I don't think I've ever presented to anybody before, is the details of the score. I also have to say that part of where this work started, I mean, I mentioned my first attempt was the conference that Eric organized in Washington 5 years ago now. And that was the first time I tried that, and I tried to isolate the effect of players. But then an offhanded comment that Matt Kane made in a Slack comment 3 years ago led me off on another garden path. And the other day I thought, I really should look that back up again, and that turned into this. So it's all Matt's fault. So we have a regression model that starts with terms for every player, for home ice, for zone effects, for the coaches themselves, for head coaches, just to try to get a handle on systematic effects. So far you might be saying, Micah, this is what you publish all the time. This is your daily model. A few of you may perhaps know that I have a website. It's a nice website. In particular, it contains a player evaluation model, and the point of that model is to evaluate players. This is not but it's very similar, because I need to know what the player abilities are to get rid of them, so that I can look at the score effect. All right, so here, there's not much technical stuff here. This is actually mathematically one of the more sophisticated things I've ever done. But the key technical bit is that we're going to fit this model with penalties that let us encode not just our intuition that the model has to fit the data, it also has to fit our prior knowledge about what we already know. In particular, we already know that all the players are NHL players. We already know a number of things, and we're going to encode that. And specifically, one of the nice things about doing things quantitatively is that you get to say how strongly you feel about things. So the subtle technical bit is that those penalties can be of two different types. You can have types that say, this term has to be close to that number. And so you can work out what an NHL average player is just by looking at a raft of NHL data without paying attention to the numbers on the backs of the players. And you can say, okay, that's league average, whatever it is, just what you see if you just take your glasses off and watch hockey. And so we're going to say all of the players can't be too far from that point, because they're all NHL players by definition. There's old jokes here. Or you can say, we're going to make these things be close to one another. We don't know what their values are, but these two things, whatever they are, they got to be similar. So specifically, this lets us use a raft of terms that would normally get us into deep, deep overfitting problems, that we're going to take 60 score terms, one for every minute of the game. We're going to break the game up into 60-minute chunks. the dreaded bins. And we're going to have a special term for the second period because it's weird, right? They play backwards. And then we're going to take even more terms for each of those minutes. We're going to have one term for every sequence of goals, every non-empty sequence of goals up to 5 goals. So us, them, us. There'll be a term for that in the 35th minute. So that's 2 to the 5 is 32. We're not counting 0, 0 because we need a reference term. So that's 31 things times 61. So anyone who knows if you can do that, 31 times 60 is, it's a lot, way too much. But then we're going to take those terms and we're going to fuse them together. We're going to say, whatever happens in the 34th minute when you're down 2-0, it's got to be, we don't know what that is. We want to learn what that is. But whatever it is, it's got to be pretty similar to whatever happens in the 35th minute when you're down 2-1, because those minutes are right next to one another. So, but then I decided not to fuse the minutes that happen to go over the period boundaries. So the 20th minute, the last minute of the first period, I'm not saying that that has to be similar to the 21st minute. After all, the coach gets to yell at the players in between. We're trying to, also they get to rest. You know, that could go in either direction. So we're trying to open up the possibilities. We're trying to encode what we know already before we look at the data. So let's get some results right away. That's a big slide with lots of stuff on it. So this is just tied. We're going to start at tied scores. And to try to make it easier to understand, try not to get into your head the idea that the graph is laughing at you because your self-esteem will go down. I tell you from experience. The A's mean the other team scored. The H means we scored. So AH means they scored, and then we tied it up. So all of these lines are about tied scores. The dotted lines are 1-1, and the solid lines are 2-2. 0-0 doesn't appear because we're using 0-0 as the reference. Everything else is in. So if you like, that 0 in this case is the reference to 0-0. So first of all, there's a bunch of things that jump out right away. First of all, the second period is up, right? Just more shots for tied teams in the second period. Second of all, the other thing that's really obvious is that the third period is less. First period's also less, but the third period's really less. And then as the third period wears on, it gets less and less and less. This is the dreaded effect that you've all seen. The games that are tied in the third period are boring. They should be exciting, but they're not. They're tense, but nothing happens. I've speculated before, in fact, I've done some much more serious work to suggest that the point system is part of the problem for this, that teams in the late third period, they imagine in their minds, in the conceit of their desires, that they have a point each, even though it's not 60 minutes. They cheat on that time, and so they make the time go away. Also notice a couple cute little details. The lines don't start at 0 because I enforced a minute cutoff. Just not a minute cutoff in the model, just a minute cutoff in the plot. So I'm just not going to show you those terms when they hardly have any data support. It's not very interesting. But in particular, you'll notice that that several of the lines seem quite close together. In particular, the 1-1 scores, those dotted lines, the red and the black at the end, they drop down more seriously than the others, and the black line is on top of the red line for a little bit. In fact, they don't appear to line up quite the same at all. So here's up 1, and this is by far the most important slide, so pay attention if you've been falling asleep. This is up 1, and in fact, I didn't even include the 5-goal states that I could have, just because there's so many of them, they clog the graph. And it turns out actually that something like 67% of the data is here just in the, 67% of the up 1 data is here in the 1-goal and the 3-goal states. So if you're up 1, then either it's 1-0, that's that H, and those are the dotted lines, or you're down, or you're up 2-1. And notice again the same pattern. Second period is up, right? Stuff happens in the second period, stuff does not happen in the third period. Notice also that if you're up, only a few of the lines are ever above 0. Even with the influence of the second period, is largely less hockey than you're expecting. And notice that all of the lines in the third period go down. In particular, the HHA line goes sharply down. That goes down to minus 30%, a third less threatening offense for a team specifically which was up 2-0 but then got scored on. This is the classic, the most consistent scoreline with risk aversion being the driving factor behind what people are saying. Right? 2-0 in the third period, we have this in the bag, but then you got scored on. Oh no. Shut it down. And so, in particular, this is the key, for me, this is the key point which suggests that it's the leading teams that are driving the behavior. Because if teams, when they were up, a team that's up has, so teams that are up have much less incentive to score than teams that are down. The teams that are down, in fact, well, let's just compare this to the next one for a second. So let's look at down one, just to complete the set of three. So notice again that the second period is higher, and the third period is less. And now, teams that are down 1 in the third are generating less and less. So that's very unusual. In particular, there's always something, every time you do anything, there's always things that you don't understand. That blue line that goes up and up and up throughout the second period, why should that particular scoreline be so different? They scored, we scored, then they scored again. Somehow that's quite different from they scored twice and then we pulled it back. Maybe that's not so surprising. They scored twice and then we pulled it back. We're on the comeback trail. We got this, especially in the second period. But then in the third period, it all falls into lockstep. Notice also that there are big changes at the intermissions. And we have strongly different behavior in the second and in the third. So you don't want to model time as completely continuous because in a hockey game, it's not completely continuous. You can worry about the whistles if you like, but you really want to worry about the intermissions, which are serious breaks. If the effect of score effects were being driven by trailing teams, you would not expect that because of course, if trailing is supposed to be exacerbated by the by the clock, we're down at the start of the third. All right, boys, let's go. If the trailing team were pushing the effect, you would expect to see perhaps suppressed offense from them, but you wouldn't expect it to get suppressed worse and worse and worse and worse as they went along. Right? If that effect is coming from the trailing team, then as the effect psychologically in the trailing team intensifies, you should expect the effect to intensify also, but it doesn't. It weakens. It diminishes. Whereas for the team that's up 1, their best interests, they don't need to score. They're quite happy. They're content to let the game diminish, even on both sides. In fact, you see that the up 1 lines, the third period lines, they go down more sharply than the down 1 lines, which is consistent with with the leading team crunching off the offense of the game. And even though they harm their own offense more precipitously than they harm their opponent's offense, that's still, so here's a calculation you have to do that I haven't done. That can still be a wise choice because they are ahead. The marginal value of a goal to them is much, much less than the marginal value of the goal to the trailing team. I inserted some slides about down 2 and about up 2, and it turns out that they just tell the same story, only not quite as clearly. So I got rid of them. So then let's look at another little tidbit. Does it matter what order the goals are scored on? I said I was going to include that. And so you might have said to yourself, it looked as though the ones with the H's at the end were consistently higher than the ones with the A's at the end. So that's one of the things that you can just measure. Turns out it's just a little bit. And well, there's the conclusion first, always the conclusion first. With a score taken as read, if the score on the bug is taken as given, then you would prefer to be the team that scored last, not the team that surrendered a goal last. By how much? So that's just a thing. Once you have all these terms, you can just compute it. You can just take the time-weighted average of all of the terms with a specific score line, with a specific score difference. You can just take all of the ones which have us scoring at the end and subtract all of the ones that have them scoring at the end within the same score difference, and then just plot the difference. And so now that blue line is tied. So first of all, even before you get into the lines, notice that almost all of them are above 0. So the advantage of being the most recent scorer is reasonably consistent across all the different score states and across all the 3 periods, with some small exceptions. So the net effect, if you average it all out, is about plus 5%. That's not huge, but 5% is good. And then, of course, the interesting question then is, where is the cause and effect there? Is it like, are we rounding into form because we're playing better, and that's why we scored, and so we're going to continue to be like that, or are we playing a little bit better because we scored? They're coincident. They happen at the same time, those two effects. Like, you see the improvement at the same time as the scoring, but tangling at the causality there is tricky. The other thing you notice is that the only things which are below the line, the only things where being the most recent scorer is bad, is if you're down 2 in the second, and if you're down 1 in the third. So that's also very unusual. Being the most recent scorer is actually a slight negative if you are down 1 in the third. That's not consistent with the trailing team's driving score effects at all. That's consistent with leading team's driving score effects. Right? If we see this momentum effect across most score states, and if the exception is, I don't want to sort of read too much into that. That deviation from 0 is not enormous. But you would expect that this momentum effect, since we see it across all hockey taken as a whole, we would expect that in particular, if trailing teams were driving score effects, then you'd get a boost from scoring to go from 2-1, from down 2 to down only 1 in the third period. And in fact, it's the opposite. The other thing we can do, and I kind of leaned into it a little bit there, is we can look at immediate goal impact. We can look at the impact of a goal on how teams behave. So now this is, a second ago we were talking about keeping a specific score state fixed, and then looking at the pattern of goals that led up to that. Would you prefer to be this pattern or that pattern? And you might say, I really don't care. 2-1 is 2-1. But you could also look into that if you were expecting, what kind of jump can I expect to see from my team in this particular spot? And also, I take a particular interest in just finding out when people say stuff on broadcasts. I like to think, let's figure it out. Is that just a thing that people say, or is that really true? So this is slightly different. This is comparing the score term behavior from a team with a particular score line, and then comparing that to the same term with another goal tacked on. So first we're going to talk about a goal scored. So it was 2-1 for them, and then you scored to make it 2-2. So that's going to be from -1 to tied. That's the red line. So what happens, what do teams do when they score? And so notice again, first of all, that the dominant reaction to team scoring, what their own offense does in the ensuing minutes, the instantaneous effect of scoring is generally to offense less. Right? All of those lines are underneath 0, almost entirely, with one exception. The one time when teams respond positively to scoring by playing offense better is the black line in the second period. So that's -2 to -1. We were down 2, now we're only down 1. We can totally bring this back. That's the only pattern where scoring appears to energize a team. Most of the time, especially in the third period, and this is the real somehow like an extremely boring version of a smoking gun, that like a -1 to tied, that red line in the third period, the first thing that teams do, if they were losing and they tie it up in the third, is they stop. It's not huge, not as bad as the specific score effect line that we looked at. So this is just the effect. So it's bizarre to imagine that you could score in the 55th minute and then just say, all right, we're good, and then just coast in. 10%, 15, maybe even 20% less, that's fine. So what about the impact of a goal conceded? What do teams do when they are scored on? So this is exactly the same thing, only now the most recent goal is a goal for the other guys, not a goal for us. And so in particular now, here the dog does not bark. Most of these lines just cluster aimlessly around 0. There does not appear to be such a strong effect. All of these graphs, part of why this one here goes down so far below that is for sort of comedic graph effect, but also so that all of the graphs are on the same scale. And just for like a rough idea, plus 20% is like the whole range, plus 20 to minus 20, that whole range is kind of like if you took Mark Stone and replaced him with some guy. Like, is that kind of, that kind of territory. So top to bottom, the difference in the graph is very large. That's, of course, a whole team effect. But that's the whole team effect you could expect by replacing Mark Stone with a person you picked out of a hat, an NHL player that you picked out of a hat. I mean, every time I talk about a person being picked out of a hat, I always worry that it's going to be me, and I can't skate. So look at this with those effect sizes down and around the 5s and 10s, and now here, where it's all compressed between -5 and +5, except one particular case. Only one case where being scored on seems to do anything at all, and that's the blue line in the third period, tied to -1. We were tied. It was the third period. We were happy. We were all coasting along nicely, but then they scored, the brigands. And then all of a sudden, now the offense turns on. And so in the second period, you see that blue line hugs tight to 0. tight to 0. We were tied, then they scored on us. It's fine. There's lots of time. No need to do anything unusual. But so teams are deliberately, well, let's not be too hasty. Supposing I've convinced you from what I said previously that the leading teams are driving the effect, this is consistent with that teams that are in a tied place who get scored on immediately, in the third period, immediately produce more offense. And it doesn't really make a lot of sense to say that if a team scores so that's the point. I'm not going to embroider that anymore. So the immediate goal impact is that teams mostly do not respond to being scored on, except when the points that they think are in the bag are taken from them. And most teams generally respond to scoring by generating less offense. Second periods are fun all the time. We saw that. That was consistent throughout all of the things. And it might be tempting to say, well, maybe that's because coaches can't get matchups. But I already took player talent out of this. This is the effect of the score, not with no player talent variation. So it can't be matchup related, because this is the independent of skater talent. It could, and so this, I think if there's a second period effect, I think it may actually be physical. The bench is further from your goalie in the second period, which forces you to play in a different way, whether your coach likes it, whether the people in the stands like it, no matter who likes it. And so all of those things together are consistent with this idea that the leading teams are the dominating factor in why we see score effects. So what are we going to go with this next? So you notice that I didn't harp on too much about home ice. That would be an extra complexity. Of course, I included home ice advantage as a term in the model to take that out. So I wouldn't be fooled by teams that happen to be leading more at home or happen to be trailing more at home. Because of course home teams win more often, so they lead more. It's, so you have to take that out. But I didn't investigate how it might interact with the score effects themselves, which would be interesting. I've heard anecdotally from some people suggesting that especially if leading teams are the ones who are driving the effect, which I feel I've now corroborated, then they expect that effect to be even stronger when the leading team is the home team. And so that I just have to look into and have not. All of this has been score effects on shot rates and shot locations without any talk about score effects on other things. I wrote up on the slide integrating score effects on penalties. In principle, we'd also have to get penalty effects on penalties because there's some evidence that previous penalty patterns affect later patterns. And so we'd want to get all of that together. We'd also like to look at shot quality that's not just locations. So that includes shooter talent, that includes do you get more rushes. I think what we saw from Megan's presentation just a moment ago is that rushes are clearly extremely important. That's not indicated here. That's not kept in here. And that's all. Thank you very much. It's a pleasure to be here.